Hi folks, let's do a review of midterm 2. Okay, so I'm gonna go over the review problems that I have given you. I'll give you an outline of how to solve these problems, and this should be sufficient for you to actually get going with the midterm 2. So the first problem is this. What are your chances of winning the mega lottery if you have to pick one mega number from 1 through 40 or from 1 to 40 and 5 regular numbers from 1 to 50. So these things you can think of it as two distinct events. So event A and event B. Event A is the event where you pick one mega or the mega number, and event B is picking 5 numbers. Okay, so let's find out how many different ways event A can happen and how many different ways event B can happen. Then we can find out how many total different ways both events can happen together. That would be the total number of ways one could potentially buy the lottery tickets. However, out of all of these, there will be only one winning number. So your chances will be 1 out of that many numbers what you get from these calculations here. So now you pick one mega number from 40 different numbers, 1, 2, 3, 4. So how many different ways can it happen? Remember, you're just picking one, so technically order doesn't matter really. So it's going to be 40 distinct items. From that you pick one, and order doesn't matter, so it's going to be combination. In the second case, you have to pick 5 different numbers from a group of 50, 1, 2, 3, 4, all the way through 50. So once again, remember, when you are selecting lottery numbers, order does not matter. Order in which you select the numbers is not important. So therefore, we are dealing with combinations. So we have 50 distinct items. From that, I select 5 distinct items where order does not matter. So we are dealing with combinations, 50, C5. Now, event A can happen in this many ways. Event B can happen in this many ways. Using the fundamental counting rule, we can say that together they can happen in this many ways. 40C1 times 50C5. Now, this is the total number of ways, okay, one could potentially buy the tickets. Now, 40C1 is pretty simple. How many different ways can you pick one number from 40 different numbers? Obviously 40 different ways times this one. You have to do the calculation, 50C5. I'm gonna let you do that. Let's say there are n different ways that could happen. So together it will be 40 n different ways these two events together can happen, meaning that there are 40 n different ways one could purchase a lottery ticket. Now, out of all these tickets, there will be only one winner. So your chances of winning the mega lottery is 1 out of 40n. Remember, this n is the number you'll get from here, 50C5. In case if you have forgotten the combination formula, which is this, NCR is equal to n factorial divided by n minus r factorial times r factorial. Remember, this n and this n is not the same. This is just, I could as well have used m here. That wouldn't make a difference, m. Okay. So this is the formula you'd be using, this formula, to you simplify this. Okay. Then you should be able to find the answer to this problem. Now the next problem is this. What is the probability of giving birth to all girls if a couple want to have 5 babies over the next 5 years? So they are going to have 5 babies over the next 5 years. We are assuming 2 genders possible, male or female, right? And each year they have only one baby, not more than one, no twins, no triplets or anything else. In this simple scenario, the probability of having at least, all 5 girls, okay, all 5 girls. So it's kind of simple. How many different ways that could happen? So think of year 1, let's call it Y1, year 2, Y2, year 3, y3, year 4, y4, year 5, y sub 5. Okay, so we want all girls, 5 girls means you have to have all girls, right? Now, how many different ways they could have the baby, or babies rather, over 5 years? Remember, there are 2 outcomes and is expanding or extending over 5 years. So the total number of possibilities is going to be 2 to the power 5, which is 32. Okay, now only one of those would be all girls. So your chances of getting all girls would be 1 out of 32. Okay. All right. Another way you could do the problem is kind of using the at least or at most scenario. Okay. Probability of at least 1 is equal to 1 minus the probability of none. So you could do this probability of at least 1 boy is equal to 1 minus the probability of no boys. Okay. By the way, probability of no boy is actually all girl, right? So if you know this, at least 1 boy, this is kind of like going roundabout way, a bit longer. You don't have to do it. At least 1 boy means you could have 1 boy, 2 boys, 3 boys, 4 boys, 5 boys, right? So that way you could think of it. And this probability you have to find, then you plug it in here and you find this one. This is unknown. No boys means all girls. But don't worry about this one. I just wanted to bring it to your attention. Okay, this is actually slightly harder way of thinking, but this is the easier way of thinking. Okay. All right. Next, we are going to talk about binomial distribution. So here, what we have is a new drug named Curates. That is 70% effective in extending the average life of an AIDS patient by 20 years or more. 5, so keyword you want to remember, 5 randomly selected AIDS patients from Africa are treated with this new drug. Answer the following questions based on the above information. Show that the above situation satisfies all the criteria for binomial probability distribution. So you probably do remember from the discussion, these are the conditions. Fixed number of trials. Okay, fixed number of trials means what? How many patients receiving this drug in this case? So n is equal to 5. Number 2 is 2 outcomes, either extends life by 20 years or not, or does not extend. Probability is constant for each patient, which is P is equal to 70% or 0.7. And number 4, trials are independent of each other, meaning independent trials. Independent trials. Okay. We are giving the medication or the drug to 5 different patients, so they are independent of each other. These patients are not related to each other in any capacity. And another thing which kind of is already done is countable, by the way. I kind of don't want to mention it, which I should be mentioning at the beginning, but since when I say n is equal to 5, it kind of implicitly assumes that it's countable. Countable means you can count them, like 0, 1, 2, 3, and keeps going. All right, so that's what this part is. Now in the next part, you need to find the probability for all of them, all the x values. So what are possible values for x? So this is part 2. So I'm just going to write it here, part 2. Okay, so that you know this is this one. Now what are the x values? The x values are x is equal to 0, 1, 2, 3, 4, 5. So if you have 5 patients receiving the drug, at the most 5 of them could be extending lives. Okay. Now in this problem, or in this part of the problem, we want you to find all the values for x. Okay, so that means find the probability of x is equal to 0, x is equal to 1, x is equal to 2, all the way up to 5. So let me just do one calculation here. Probability of x equal to maybe 4. Okay, remember binomial distribution formula, p of x is equal to n c x p to the power x times 1 minus p to the power n minus x. So using that formula, my n is 5, so 5c4, right? X is 4 times p is 0.7 to the power 4 times 1 minus 0.7, 1 minus p to the power 5 minus 4. So NC4, 5c4 is just 5, by the way. And 0.7 to the power 4, you can do the calculation using a calculator. 1 minus 0.7 is 0.3, 5 minus 4 is 1, but 0.3 to the power 1 is just 0.3. Now this is going to be the probability for that 4 patients out of 5 extend their lives by 20 plus years. Now this is exactly the same way you do other calculations for 0, 1, 2, 3 and 5. Okay. Next, find the probability that more than 4 patients extend their lives. Remember, we have 5 patients at most, right? Or 5 patients who received the drug. So probability of more than 4, x more than 4, right? Which is the same as probability of x is equal to 5. That's exactly what it is. Find the probability that more than 4 patients extend lives. So you just need to find this. Find the probability that less than 2 patients extends lives. So you need to find probability of x less than 2, which, by the way, is this. Probability of x is equal to 1 plus probability of x is equal to what? 0. That's what it is. You need to find that. Find the probability that more than 2 or less than or equal to 4 patients. So probability of more than 2, right? 2 less than x or less than equal to 4. So in this case, you just have to do probability of, remember, x cannot be equal to 2. X is less than, 2 is less than x. So that means another way of, or equivalent way of saying the same thing is that probability that more than 2, okay, more than 2, x is more than 2, or equivalent statement is 2 is less than x. Okay, so it's going to be probability of x is equal to 3 plus probability of x is equal to 4. And you just find these probabilities the way I showed you in part 2 and add the results. That should be your answer for this part. This is another example of binomial distribution. Okay. A student takes a multiple choice test consisting of 10 questions and 5 choices for each question, so that it satisfies all the conditions of binomial probability distribution. So number 1 is countable, or fixed number of trials in this case, and fixed number of trials. In this case, how many questions are you answering? 10. So n is equal to 10. Number 2, 2 outcomes. You either get it right or what? Wrong, right? Number 3, independent. Each question is independent of any other questions, right? You have 10 questions. One question is independent of any other questions. So they don't depend on each other. No 2 questions depend on each other. Number 4, probability is constant, or P is constant for each trial, meaning for each question the probability is constant. Of course, there are 5 choices, so your chances of getting one question right by random guessing is 1 out of 5, right? So 1 out of 5, which is just 0.2. Now, we use the binomial distribution formula to find the probabilities, rest of the problem. So find the probability that a student gets exactly 5 questions right by guessing, right? So remember the binomial distribution formula. Probability of x is equal to ncx p to the power x times 1 minus p to the power n minus x. And you have all the components of this formula. So in this particular problem, x has to be 5. That means you get 5 questions, right? And n is equal to what? 10, and p is equal to 0.2. You just plug in these numbers here. If you do so, you're gonna get this 10c5 times 0.2 to the power 5 times 1 minus 0.2 to the power 10 minus 5, and you should be able to simplify it. Find the probability that the student gets less than 2 questions right by pure guessing. So less than 2, probability of x less than 2, meaning probability of x is equal to 1 plus probability of x is equal to 0. Obviously you cannot get less than 0 question, right? Similarly, you're going to find another one here. Find the probability the student gets more than 8 questions right. So probability of x greater than 8, how is it going to be? Is going to be probability of x is equal to 9 plus probability of x is equal to 10. It cannot be more than 10 because there are only 10 questions. X cannot be more than 10. So that's what this part is. Now, in this part, 70% is the passing rate. Then what is the probability that a student passes that test by pure guessing? So 70% passing, so that means 70% of 10 questions, 70% of 10 questions, right? Which is, by the way, just 7, right? Now you need to find the probability of passing. So probability of passing. So that means you have to get probability of x is equal to 7, meaning that you get 7 questions right. Now the catch here is this, folks. If you get 70%, meaning 7 out of 10 questions correct, you pass. However, what about if you get 8? Do you still pass? Of course you do. How about if you get 9 correct? Do you still pass? Yes, you do. How about 10 correct? Do you still pass? Yes. So passing rate is at least 70%. So you have to add all the probabilities beyond 70%. So probability of x equal to 7, meaning you have to calculate this, and then probability of x is equal to 8 plus probability of x is equal to 9 plus probability of x is equal to 10. That's what it is. So you have to do calculation for all these 4 different scenarios, okay? And at the end you add up all these probabilities, and that should give you the probability of passing just by purely guessing. All right, so this concludes our problems with binomial distribution. Next we are going to talk about Poisson distribution. So this is a Poisson distribution problem in Dhaka, which is a city in Bangladesh, the capital city of Bangladesh, where 3,600 patients visited emergency medical care facilities over 1 year. Find the probability that tomorrow there will be exactly 32 patients visiting emergency healthcare facility in the city. So pay attention to the case that 3,600 over 1 year, okay, but they want 32 in a single day. So if you have 3,600 patients visiting emergency care in 1 year, in 1 day, how many? So there are 365 days. For some reason I meant to say actually something different, but I'll change the number a little bit for calculation purposes to make it simple. There are 365 days in a year, so make it just 360 days in a year for simplicity. But this is incorrect. Remember, it's not exactly correct. It's just for the sake of calculation. You know, on a second thought, I have a calculator right here, so I'll just do it for you. So ignore my last comment. So mu on a daily basis, how is it going to be? How many patients are there? So 3,600 divided by 365. So per day, so 3,600 divided by 365, which is about 9.86. So okay, 9.86. That's your mu. Now remember, look up the conditions for Poisson distribution. So what it is, of course, it's still countable. You can count them 1, 2, 3, 4, and you know how many has happened in the past, but you don't know how many are likely to happen in the future. Okay, so on the average over the last year, we know that about 9.86 or roughly about 10 patients visited the emergency care facility every day, correct? So whatever has happened in the past, you have data about that or information about that. However, you don't have any data about what's gonna happen in the future. So that's the key distinction between Poisson distribution and binomial distribution. In the binomial distribution case, you exactly know how many are likely to happen, but in Poisson, you don't. And of course, it happens over a window of interval of time, right? Or interval of area or volume or whatever the thing under consideration. In this case, our window is daily, right? Window of time. And trials are independent of each other. That means one does not influence the other. In this case, one patient coming into the hospital is not going to be dependent on another patient coming to the hospital, right? They are pretty independent of each other. So these are the conditions of Poisson distribution. And if it is satisfied, the probability is defined as P of x is equal to mu to the power x times e to the power negative mu divided by x factorial. Now the problem wants you to find out what is this probability going to be. This probability is going to be, by the way, extremely small. Your calculator might give you really small number. So probability of x equal to 32 is going to be mu to the power, oops, not mu, I meant to say 9.86 because mu is 9.86, right, to the power 32 times e to the power negative mu. Negative mu is negative 9.86. All of it divided by x factorial. X is 32 or 32 factorial. And use your calculator to simplify it. I kind of want to make it simple in a way. So I gave you this problem, and this should give you an idea about Poisson distribution. So let's go ahead and move on to the next important topic, which is expected value, a very important concept. So let's talk about expected value. Expected value is defined as, we are dealing with a discrete probability distribution. Expected value is defined as summation x times p of x, and it's typically denoted by e of x, means expected value. So American roulette is a form of gambling where you have 38 total choices or 38 different options, 1 through 36, 1, 2, 3, 4, all the way to 36, then 0 and 00. Calculate the expected return for a gambler who bets $1 on 3 consecutive numbers, right, 5, 6, and 7. The return is 12 times if either 5, 6, or 7 shows up. So easiest way to do is to create a table x p of x and x times p of x, or probability of the event x. Remember, x is some event that's supposed to have taken place, and this is a random event. Always we think about x as a number, and yes, it is true in mathematics. When we are using a variable, it's typically representing number, but in probability you have to think about it not as a number but rather as an event. Of course, an event could be a number too. But in this case, think of it as an event, and this event is kind of like binary. You either win or you don't, right? So there are two choices here. You either lose $1 or you get 12 times the amount you bet, which is $12, okay? Because you bet $1. So if you win, that means if one of the 3 numbers show up, 5, 6, or 7, you'll get 12 times the invested amount, okay, which is going to be $12. So in your one case, you're going to lose $1, okay. That's one outcome of the random variable x. The other outcome of the random variable x is that you win. That means in that case you get $12. Now, what are the chances that you will get $12? Remember, there are 38 different possibilities, right? 1 through 36, 0, and 00. Now, you bet on 3 different numbers, so it's going to be 3 out of 36, your chances of winning, okay? 3 out of 36. So your x times p of x is going to be 12 times 3 out of 36. 6. That's one option. The other option is that you lose, right? What are your chances of losing $1? That's, by the way, 33 out of 36. Why is it 33 out of 36? Because there are 3 winning numbers, 5, 6, and 7, right? So if you take away 3 numbers from total 38 numbers, you're going to be left with, oops, not 33. Oops, I made a mistake. It's 35 out of 38, and also there's a mistake here. 3 out of 38. Sorry about that. I just looked at this 36 and it came to my mind 36. I forgot about 0 and 0, 0. So your chances of winning is 3 out of 38. So it's going to be this 3 out of 38. The other option is 35 out of 38. So look, negative 1 times 35 out of 38 is going to be negative 35 out of 38. Okay. And this is going to be 12 times 3 is 36 out of 38. Okay. Now you need to add these two. If you add these two, you're going to get your expected return. Negative 35 out of 38 plus 36 out of 38, which is just negative 35 plus 36 is 1, right? 1 out of 38. So your expected return in the gambling is 1 out of 38. By the way, I just made this problem up so that expected return is positive in your favor, but in reality this will be an expected return for the house. Okay. Your expected return as a player is always negative, meaning you lose money. Okay, this is just an artificial problem that I just created up, but it reflects the reality. So no worries. The main concept is to make sure that you understand expected value scenario. Again, we are going to apply the expected value situation in health insurance. So I'm going to just jump into this. Again, the same thing. X, P of X, then X times P of X. Okay. You buy the health insurance for $10,000. Okay. So let me use a different color so that you can see it. $10,000 you buy health insurance, and $4,000 you get reimbursed for healthcare expenses if you get sick, and there is a 70% chance that you might get sick. So this is the scenario. Now X is the random outcome or random variable in this case. You have two options. One option is you lose all of $10,000. If you don't get sick, you lose everything, right? You don't get any money back. However, if you do get sick, you get $4,000 on the average. Okay, a policyholder either loses $10,000 or gets $4,000. Now, here's the question: what are your chances of getting sick? 70% chance, or 0.7 chance that you will get $4,000 in reimbursement. So 0.7. So 0.7 times 4,000 is, by the way, $2,800. Okay. Your chances of getting sick is 70%. Chances of not getting sick is what? 30%, right? 100 minus 70 is 30. So that's going to be negative 0.3 times 10,000 is negative 3,000. Now if you add these two numbers, you're going to get negative 2,000. So your expected return as an insurance buyer is $2,000, but negative, meaning that on the average, an insurance buyer pays $2,000 out of pocket. Where does that $2,000 go? That $2,000 goes to the insurance seller. So that's how insurance companies make money. Your expected return is negative, meaning expected return for the insurance service provider is positive. Similarly, in the gambling case, your expected return is supposed to be negative, even though I made it positive here, right? So look here, your expected return is negative in gambling, or as a matter of fact, any insurance or anything gambling. You as a player, your expected return is negative, meaning the service provider, their expected return is positive. Otherwise, the insurance companies won't survive. So that's what it is. So here is another expected return problem. you're investing $10,000. So this is your $10,000 you're investing. There are two types of investments, bond A and bond B. First bond is 7% return with default rate of 4%, and the second bond is 9% return with default rate of 6%. Which one of these bonds should you consider investing $10,000, given that you want to what? Maximize your return on the investment. So you just have to do the expected calculation for the first bond and expected value calculation for the second bond, and then see which one is higher. That's the one you want to invest in. All right. So let's go ahead and do it for the first bond. So let's call it bond A and bond B. So that's easier. Okay. So your X, P of X, and X times P of X. Now, in the first case, what you get is 7% return, 7% of $10,000, which is, by the way, 0.07 times 10,000, so that's $700. Okay, that's one option. But at the end of the year, you either get $700, or if the bond issuer goes underwater, meaning they go out of business or declares Chapter 11, in that case, if they declare bankruptcy, in that case, what happens is this. You lose all of your $10,000. So your other option is lose all of $10,000. Now, what are your chances that you lose all of $10,000? Only if they go out of business, or only if they declare bankruptcy, and the chance of that happening is the default rate. Okay, the bond issuer defaults, meaning there is a 4% chance, or 0.04. Okay, there is a 4% chance that they will go out of business. However, complement of that in the context of probability would be 96%. 100% minus 4% is 96%. Or 96% chance, or 0.96 chance that they will stay in business. If they stay in business, they have to give you $700. So your X times P of X, X times P of X is this column. So it's going to be 700 times 0.96. And then the bottom one is negative 10,000 times 0.04, which is, by the way, negative 400, right? And this number, let me just quickly calculate it on the calculator. 0.96 times 700. 672. Now, if you add these two, you're going to get 272. So your E of X, expected return for bond A, is 272. Now, in exactly the same way, you do the calculation for bond B, okay? And you'll come up with a number like this. Whichever number is higher, that's the one you want to invest your $10,000 in, because the value, expected return, is going to be higher on a bond, right? Whatever bond it is, one of these two, is the one that should interest you, because you want to maximize your financial return or financial gain. And just to give you a quick heads up how to set it up, the second part, second one gives you 9% return. So this is going to be, instead of 700, is going to be 900. The other option is you lose what? 10,000, right? And what are your chances of losing 10,000? Default rate is 6% or 0.06, right? So the other option is you do not lose 10,000, you get $900, which is 100% minus 6% default rate, which is 94% or 0.94. And you do the calculations here, multiplications, and add the results, and you should get your expected return from bond B. So that should be another number that you will get. Between this number and this number, whichever is higher is the one that you want to consider. That means you invest in the corresponding bond. So that kind of ends expected value calculation problems. Now we are going to jump into uniform distribution or probability distribution with continuous random variables, which we call probability density function. And the first distribution we are going to talk about is the uniform distribution. For a uniform distribution, by the way, guys, This is what the scenario. The definition is density function f of x is equal to 1 over b minus a. So is defined over an interval a to b, closed interval, and this is the definition of the function. And now a mean of the uniform distribution is mu is equal to a plus b over 2, and the variance sigma square is a minus b whole square divided by 2. Remember, standard deviation is the square root of variance, so sigma is equal to square root of sigma square. Remember, sigma square is the variance, right? Sigma square is the variance. So if you are given variance, you can find standard deviation just by taking the square root of the value, or if you are given standard deviation, by squaring the value you get the variance. Now let's go ahead and talk about this problem. Your school wants to test what is it, a fire alarm between 10 a.m. and 2 p.m. Okay, the probability of happening the event, probability of the fire alarm setting off is in this window is uniform, meaning the probability is always the same. It's a constant probability. It could happen anytime over this window of 4 hours. Okay, so it's uniformly distributed, and u is the symbol. So random variable x, this tilde tells you the distribution of x, the random variable uniform from 0 to 240. Where does 240 come from? 4 hours is 240 minutes, right? 4 times 60 is 240. On the average, how many minutes do you have to wait? You know, just mu is equal to a plus b over 2. Your a is 0, right? A is equal to 0 and b is 240. And you can do the calculation. What is the variance? Remember, sigma square is equal to a minus b whole square over 12. And you have a, you have b, and you have a, and you can do the calculation. Find the probability that you will wait 140 minutes for the alarm to go off. That is, find the probability that 0 is less than x is less than 140. Remember, for uniform distribution, probability is constant. So let's say this is 10 a.m. and this is 2 p.m. Okay, probability is constant. So 140 minutes. So 60. So let's divide it into hours and minutes. So this is 1 hour, 60. This is 2 hours, 120, 140 would be right here. Okay, 140. So probability in the continuous case, remember, probability in the continuous case is the area under the density curve, under the density curve or density function, right? Density function or slash curve, doesn't matter. So that means you have to find this area. So this area. So that's gonna be width times height. What is the height? Remember, area under the curve must always be equal to 1. So everything from here to here must be 1. If this width, we talked about it in the class, if this width from here to here is 240, because 10 to 2 p.m. 240 minutes, height must be 1 over 240. Why is it 1 over 240? Think of a rectangle with width 240, okay, with some height, right? We know that the area, total area is 1. So if the width is 240, what is the height? Height is going to be 1 over 240. Why is it 1 over 240? Because 1 over 240 times 240, length times or width times height is going to be what? 1. So 1 over 240 times 240 is 1. That's the area under the curve. So you just have to use that. So your area, this shaded region, this region is going to be 1 over 240 times what? 140. So that's going to be the probability that you have to wait more than 140 minutes, so which means you have to find this area. Let's use the yellow here. I don't know if you can see it clearly. This area, which should be pretty easy. If up to here is 140 and up to here is 240, so this window is 100, right? So your area is going to be 100 over 240. That's the probability, this probability. Okay. Next, find the probability that you have to wait exactly 40 minutes. Remember, in the continuous case, probability of a single point is always 0. Exactly 40 minutes would be somewhere here. Let me use the red here, somewhere here. Okay. So you have some height, but width is 0, right? So the area becomes 0. Height is 1 over 240. But the single point, its width is 0. 1 over 240 times 0 is 0. So probability of a single point in the continuous case is always 0. Probability that the alarm exactly goes off at 40 minutes is 0. This is kind of strange and counterintuitive, but the way the definitions work out, it does come out to be that way. I think it has something to do with uncountability of points on the number line. The next one is between 180 and 210. So what is the probability that the alarm will go off between 180 and 210? The difference between 180 and 210, so 180 would be somewhere here and 210 is going to be somewhere here. So you have to find this area, right? So it's going to be 210 minus 180, which is, by the way, 30, okay, divided by 240, and there should be your answer for this part. Now let's talk about all important normal distribution, very important concept. Just to remind you, normal distribution or bell shape or Gaussian distribution is this shape, but when the mean is 0, mu is equal to 0 and standard deviation is equal to 1, this becomes standard normal distribution. When you have a normal distribution that has a mean 0 and standard deviation 1, we call it standard normal distribution. To find the probability associated with any normal distribution, we need to convert it into a standard normal distribution and look it up in the standard normal distribution table. How do I go from any normal distribution to standard normal distribution? We use the z-scores formula or z formula. Now, in this problem, what's given? Excluding extreme values, we exclude outliers or extreme values. The income in a city is normally distributed with an average of 45,000 and a standard deviation of 15,000. So we are claiming that is bell shaped like this with a mean mu is equal to 45,000 and standard deviation sigma is equal to 15,000. All right. Now, what is the probability that somebody makes less than 30,000? So 30 is going to be somewhere here, right? 30,000, right? Probability that someone makes less than 30,000 would be the area under the curve, area under the normal distribution curve to the left of point 30,000. So it's going to be all the area to the left. However, we don't know, okay? We don't know how to calculate this one using regular normal distribution. We have to convert it into a standard normal distribution with a mean of 0 and a standard deviation of 1. How do I go between these two? We use the z-scores formula, right? Z is equal to x minus mu over sigma. X is the point of interest, right? So 30,000. So 30,000 minus mu is 45,000 divided by sigma is 15,000. 15,000. So that gives you what? 30 minus 45 is negative 15,000, right? Divided by 15,000 is equal to negative 1. So probability of x less than 30,000 is the same. So this is going to be z is equal to negative 1. So this area in the standard normal distribution curve is the same as this area in the other normal distribution. So this is the same as probability of z less than negative 1. Now you can look it up from the standard normal distribution table, from the z-scores table. For z is equal to negative 1, you will see is 0.01587, I think. 1587, that's what it is. Similarly, for x greater than 60,000 is going to be just on the other side, right? This is mu 45k, and you want to go to 60k, right? And this is moving one standard deviation to the right, so all the area to the right. So if you go to standard normal distribution with a mean of 0 and standard deviation 1, and you do the calculation using the z formula, right? Z is equal to x minus mu over sigma. You will find z to be 1, by the way, and that's this area. So probability of x greater than 60,000 is the same as probability of z greater than 1, and you can see that is also 0.1587. Right? Find the corresponding income for an individual if the person's z score is negative 1.35. So z is equal to x minus mu over sigma, right? In this case, you are given z, you need to find x. In this problem, you are given x, you have to convert it into z, right? It's just going the opposite way in this one. So z is negative 1.35 is equal to x is the value we are looking for. Mu is 45,000, right? And sigma is 15,000 is given. This information is given in the problem, sigma and mu. And then you need to solve for x. The easy way to do it is multiply both sides by, so multiply these by 15,000, multiply these by 15,000, right? This and this is going to cancel out. That's going to give you x minus 45,000 is equal to negative 1.35 times 15,000. Then obviously you can solve by simplifying this thing. Pretty straightforward. The next problem is income below which one would be considered at the bottom 5%. So this is how it looks like. Your mu is 45,000, sigma is 15,000, right? You want to find the income level that's going to put someone in the bottom 5% or 0.05, and you are looking for this x. So to find that, we kind of have to go back to standard normal distribution with a mean of 0, standard deviation of 1. We are looking for 0.05 area to the left, okay, because you want to be in the bottom 5%. And that value, this one, how do you find this z value? You have to be careful. You look inside the table. Look inside the table, okay, and then look for the value that is closest to 0.05, and as it turns out, it's negative 1.645. Z is equal to, that's your z. So we use the formula z is equal to x minus mu over sigma, right? Z is negative 1.645, right? X is the value we are looking for. Mu is given 45,000 and sigma is 15,000. Then, like the way I did it here, do the exact same thing. Multiply both sides by 15,000 and solve for x. Now this problem is, by the way, this part of this normal distribution problem is exactly like the last one. Instead of bottom 5%, we are talking about the top 5%. So again, is this thing. This time you are looking for the right side. This should be 0.05 or 5% in the top category. 45,000 and 15,000. 15,000 standard deviation. And in the standard normal distribution, if you consider the right side, 5% top, your z is going to be 1.645. By the way, compare this with the last one. Last one had bottom 5%, it had negative z value, negative 1.645. This one is top 5%, which is going to be 1.645 positive, because normal distribution is symmetric about the middle, right, about the mean. So it's a mirror, left half is a mirror image of the right and vice versa. So the last one was negative 1.645, this one is going to be 1.645. And what do? Your z is equal to x minus mu over sigma. Z is 1.645 is equal to x minus 45,000 divided by 15,000. 15,000. Now multiply both sides by 15,000 and simplify. That should be your answer. Now find the income for the middle 80%. So this one I will just give you a hint. Middle 80%. So this is going to be 80%, right? Total area under the curve is 100%. So, and you know that this is a left is a mirror image of the right. So if the middle is 80%, the outside, this and this must be 20% together. However, they are mirror images, so this right side is going to be 10% or 0.10. This left side is going to be 10%, which is 0.10. Okay. Now, all you need to do is this: find this value. And this value, right? But we go back to our standard normal distribution. Okay, 0, mean, standard deviation 1. So we want this to be 10% or 0.10. We want this to be 10% or 0.10. You look it up in the table, you should get a z value. I don't remember what the z value is. And let's say for simplicity, this z value, this is not the exact number. I'm just saying this z value is negative 1.2. I just made it up. Okay, so this is going to be negative 1.2 and this is going to be positive 1.2. By the way, this is not the exact value. You have to look it up. Look inside the table and look for an area of 0.110, the closest value to 0.10, and then you look at the corresponding row and corresponding column. That's going to give you the z value. I'm saying that if this z value were to be negative 1.2, if it were to be negative 1.2, then this is going to be negative 1.2 and this is going to be positive 1.2 because they are mirror images of each other. Then you just would find the corresponding value for this. So in one case it's going to be negative 1.2 is equal to x minus 45,000 over 15,000. In the other case is going to be 1.2 is equal to x minus 45,000 over 15,000. And then you find two values. So one of the values is going to be this one, another value is going to be this one. So that means, let's say hypothetically speaking, one of the values is 40,000, another is let's say 50,000. So if you made between 40 and 50,000, you'd be among the middle 80% of the socioeconomic status. Okay, that's how you do the problem. Very straightforward, very standard application of normal distribution, very important. So make sure that you know how to do this, and I'm going to be asking questions on this for sure in the midterm. Now the next problem is kind of like an application of normal distribution. So let's go ahead and work on that. So in this one, lifetime of a smartphone is normally distributed with an average usable lifetime 48 months right here, and standard deviation 12 months. If you want to purchase insurance policy so that 95% chance that your phone will be fixed, okay, if it is broken, what should be the length of time? So it's bell shaped, okay. So mean is 48, standard deviation is 12. You want 95% chance to be fixed, so that means you want to go all the way up to here so that area to the left becomes 0.95. Okay, so this all the area to the left is going to be 0.95, and this area to the right is going to be 0.05, right? Why is it 0.05? Because area to the left is 0.95. 1 minus 0.95 is equal to 0.05. Now what is this value you need to find? Look, if you look at the standard normal distribution, exact same thing, area to the right is going to be 0.05, and we know from our calculation previously that this z value is 1.645. okay, positive. Now you just use the formula z is equal to x minus mu over sigma, or z is 1.645 is equal to x minus mu. Mu is 48 months, right? Divided by sigma is 12 months. Now multiply both sides by 12, right? And then simplify. That should be the answer. So that should be the number of months for which you should get the insurance for. Exact same problem here with GPA. exact duplicate problem. I just changed the word. With GPA, mean is 3.3, standard deviation is 0.2, right? You want to give scholarship to top 15.87%, so it's going to be this. On the top is going to be 0.1587. We know, you can look it up, this, this is not Z, this is X, right? So this is X, and if you go to standard normal distribution, this is going to be top 15%, right? Or 15.87%. So that's going to be Z, and we know from experience of dealing with it many times that Z is 1. So what is this great point that you should be announcing to ensure that only top 15.87% of the students get the scholarship, get to apply for the scholarship, which is going to be easy. Z is equal to X minus mu over sigma, and Z, by the way, in this case is 1, is equal to X minus 3.3 divided by sigma is 0.2. Then you multiply both sides by 0.2 and solve for X, and that should be your GPA. And I could give you the answer, even it's going to be 3.5, by the way. So that takes care of this. Now let's talk about the central limit theorem. So CLT, or central limit theorem, which is central to the study of statistics, probability and statistics, okay? And there are two conclusions. Remember, if your sample size is greater than or equal to 30, okay, mean of the sampling distribution, which is mu sub x bar, is the same as the mean of the population. So that's conclusion number 1. And the conclusion number 2, again, assuming that sample size is greater than or equal to 30, standard deviation of the sampling distribution is the same as the standard deviation of the population, which is sigma, divided by the square root of the sample size. These are the two conclusions. Now, these restrictions on the sample size applies only if you do not know the distribution of the original population. However, if the original population happens to be normal distribution, in that case, you don't have this restriction. Your sample size could be as small as 2. Obviously, you cannot have a sample size less than 2, right? If you do, there would be 1, right? One sample size of 1 applies to or refers to population itself. So if your original population is bell shaped, you can have any sample size. That means n could be 2, 3, 4, 5, 6, 7, 8, 9, 10, or whatever, right? But if your original population distribution you don't know, in that case you have to make sure that this is what? Greater than 30, or your sample size is greater than 30. Why does it have to be greater than 30? Remember, that ensures that the sampling distribution is bell shaped if your n is greater than or equal to 30. If n is not greater than or equal to 30 and your original population distribution is unknown, that means it's not normal. In that case, it does not ensure that this is normally distributed. All right, so let's go ahead and do this problem. This should be pretty straightforward. What is it? Mr. Zach, the founder of Facebook, recently announced that an average person spends 60 minutes per day on social media. Assume that time spent on social media, social networks, is normally distributed with standard deviation 20 minutes. Okay, if you now take a sample of 25 people who use social media, then what is the average of the sampling distribution with sample size n is equal to 25? So what they are asking, mu sub x bar is equal to what? But from the first conclusion, look, from this conclusion we know that mu sub x bar is equal to what? Mu, right? So this is going to be just mu, which is given in the problem, 60 minutes. What is the standard deviation of the sampling distribution? So sigma sub x bar. So remember, sigma sub x bar is equal to sigma, that means the standard deviation of the population divided by the square root of the sample size. Standard deviation of the population is given to be 20. So this is going to be what? 20 divided by what? Square root of the sample size, which is 25. So 20 divided by square root of 25 is 5, which is going to give you 4 because 5 goes into 24 times. So standard deviation of the sampling distribution is 4. Now find the probability that a randomly selected person spends more than 100 minutes on the social media. Which is this probability of x greater than 100? You just have to take the population distribution. Remember, this is the population, okay? Distribution, which is bell-shaped. Mu is 60, so 100 would be somewhere here. So probability that someone spends more than 100, and you should know how to go from here to the standard normal distribution, right? Z, as you can see, Z is going to be 2 in this case. So because standard deviation is 20, so 60 to 100 is going to be 20 plus 60 is 80, 1 standard deviation. 80 plus 20 is 2 standard deviation, which is 100, right? So this is this. You guys already know probability of x greater than 100 is the same as probability of z greater than 2, which by the way is the same as probability 1 minus the probability of z less than 2. Remember, a normal distribution table is cumulative from the left, right? So it gives you area to the left when you look at the corresponding value for z, right? Z gives you a corresponding probability value. That area is to the left, not to the right. So we want the right, so we have to subtract it from 1. That's why to find this, we just subtract probability of z less than 2 from 1. That's going to give me 1 minus, I think for z the value is 0.9772, which gives you 0.0228. Okay. Find the probability that 25 randomly selected persons spend more than 100 minutes. So this one is the interesting one. Remember, this time, however, you are not dealing with population distribution. You are dealing with sampling distribution. Okay? Distribution with sample size n is equal to 25. So this is the pop or population, and this is the sampling distribution. Now, central limit theorem tells you mu sub x bar is equal to mu. That means mean of the sampling distribution is the same as the mean of the population, which is, by the way, 60. However, standard deviation of the sampling distribution is not the same as the standard deviation of the population, which is sigma over square root of n, and we found above that value to be 4, right? Now, what is the probability that average of 25 people? Now you have to use x bar as opposed to x that you used here, okay? Because for 25 people, x does not make sense. It has to be x bar greater than 100. So you just have to find out how many standard deviations are you moving from in going from 60 to 100 in the case of sampling distribution. For the population, you just moved 2 standard deviations, right? You just moved 2 standard deviations, one here, one here. But here, how many standard deviations are you moving from going from 60 to 100? By the way, 40, right? 40 is the unit distance, but standard deviation is 4. So if you have to go from 60 to 100, how many jumps do you have to make? That's 10 jumps, because each jump is 4, right? Each standard deviation is 4 units. So 10 standard deviations is going to be 10 times 4, 40. But there is a way to find that value, right? We know that mu is equal to 0, standard deviation is equal to 1, z sub x bar is equal to x bar minus mu sub x bar divided by sigma sub x bar. And we know all of these value. X bar is the point of interest, 100, minus mu sub x bar is 60, and sigma sub x bar is 4. So 40 divided by 4 is equal to 10. So z sub x bar is equal to 10. So that means you're moving 10 standard deviations away, which is way out there, right? All the way down there. So it's probability of z sub x bar being greater than 10, which is the same as 1 minus the probability of z sub x bar, 1 minus the probability of z sub x bar being less than 10, right? Because that gives you area to the left. Now this area, is so big because 10 standard deviations, it's all the way out. Your table doesn't go even beyond 3.5 standard deviations. So it's going to be 1 minus 0.999, I don't know, probably bunch of nines, and is equal to 0.000000, bunch of zeros, 0, 1. Okay, your chances of average of 100 people being average of 25 people being more than 100 minutes per day is extremely small compared to single person. Look, for a single person, the fluctuation or the variance is higher, right? In that case, what you get is this. Probably that one person, one individual will talk more than 100 minutes a day is about 2.28%, but probability that the average of 25 people will be more than 100 minutes a day is extremely small. That's where the power of central limit theorem comes. Okay, it tells you exactly how does the distribution change when you increase your sample size. It becomes very compact, very narrow. That means you are restricting yourself very close to the mean. Your variance is extremely small compared to the original population distribution. Now find the probability that a randomly selected person spends between 40 and 80. So which is the probability of 40 less than x is less than 80. Okay. Now I'm just going to quickly draw something here. So 40 is here. Okay. 80 is here. And middle is 60. So it's like going one standard deviation to the left, one standard deviation to the right. You want everything in between. And you can convert 40 to z value is going to go to z is equal to -1, and 80 if you convert to z value, z is going to be 1. So probability of -1 is less than z is less than 1, which is just going one standard deviation to the left and one standard deviation to the right, which is empirical rule, right? Remember 68%, or we know it more precisely, it's 68.26. That's what the value is. Okay, now I'm going to just write one more extra step here to ensure that you understand what's going on here. You want the area between -1 and +1 in the z or standard normal distribution, right? This is -1, this is +1, that's the z value, right? You want this area. So you're going to write it as probability of z less than 1 minus the probability of z less than -1. And if you look this value and this value and subtract one from the other, you'll get this value. And by now you should know how to find this value and this value from the table. Now the interesting part is this. Instead of considering one person, you're considering 25 people. Again, everything is the same. Only thing is going to change is the standard deviation. So now to go from 60 to 80, by the way, and from 60 to 40, so what is the probability? Remember, this is the sampling distribution, or SD. This is the population distribution, or PD. Okay, probability that the average of 25 people falls between 40 and 80. So 40 is less than x bar. Remember, this is x bar. Okay, and this is x. Whenever you see x, it means it relates to the population. Whenever you see x bar, it's going to be relating to the sampling distribution, to not 60, 80. X bar is between 40 and 80. So now remember, sigma sub x bar is 4, right? We found it in the previous part of this problem. So how many standard deviations you have to move from the mean from 60 to get to 40? 20 is the distance. Each standard deviation is 4, so that means you have to move 5 standard deviations, because 20 divided by 4 is 5. But remember, you can use the formula. You have to use z sub x bar is equal to x bar minus mu sub x bar divided by sigma sub x bar. That's going to take you to this guy. Standard, I don't like my standard normal distribution drawing, so let's make it a little nicer. 0 and 1. So where does this point map to? Somewhere here, right? And this point maps to somewhere here. You need to find these z values, and this area in between is going to be the same as this area. Okay, these two areas, green here is the same. Now how many standard deviations are you moving? As it turns out, a lot. X bar is 40 minus mu sub x bar is mu by first conclusion of the central limit theorem, which is 60 divided by 4. So z sub x bar is going to be 40 minus 60 is negative 20 divided by 4, which is negative 5, right? So this is going to be negative 5. And by mirror imaging, because it's symmetric, this is going to be positive 5. So your probability of x between 40 and 80 is the same as probability of z sub x bar being between negative 5 and positive 5, which is the same as probability of z sub x bar less than 5 minus probability of z sub x bar being less than negative 5. Once again, still these values are extremely extreme. 5 standard deviations to the right, your table only goes to 3.5 standard deviations, and then 5 standard deviations to the left, your table only goes to 3.5 standard deviations to the left. So this is going to be just like, so let me bring it down here, it's going to be like 0.999999, something like this, minus this is going to be 0.00000. I'm just putting bunch of 00, and which is approximately 0.9999 something, right? That range, or at some point there will be an 8. So this is how you do this problem. The moral of the story is probability that individual, so let me highlight it, probability that an individual talks between or spends between 40 and 80 minutes in the social media is approximately what? 68%. However, probability that the average of 25 people falls between 40 and 80 is extremely high. Again, it says that by increasing the sample size, you are making this normal distribution very narrow. So if the population normal distribution looks like this, the sampling distribution normal distribution looks like this. That means variance goes down significantly, or the standard deviation goes down significantly. Remember, in this case sigma is the standard deviation. In this case, sigma over square root of n is the standard deviation, which is denoted by sigma sub x bar. That's what it is. So this square root of n, if your n becomes bigger, sigma being fixed because the population standard deviation doesn't change, right? For the purpose of calculation, it stays the same. Then if you increase n, this denominator becomes smaller, bigger. As a result, sigma over the denominator becomes smaller and smaller, and that's why this becomes narrower and narrower. So if you want to get truly, or not truly, very, very close to the reality, or very close to the true mean of the population, you have to increase the sample size, which kind of, by the way, conforms with your common sense, right? If you increase sample size, given that your sample size represents the population, your accuracy becomes higher. You become more accurate in your calculation. In a sense, you become more confident in your calculation. That, by the way, is the next topic we are going to talk about, confidence interval. Okay, how confident are you in your calculation? And we will be using the central limit theorem, where we introduce the concept of sampling distribution. Okay, if you increase your sample size, your confidence level goes up. All right, I think that kind of ends everything. Let me just double check. Yes, that is all. I have given you an overview of all the problems that I have put on the midterm review, and I have given you more than enough information on how to solve these problems. Pretty much I have solved the problems for you. You just need to do the simple calculations, conceptual underpinnings, and theoretical understanding. Everything I have given you, and I have shown you the steps how to do these problems. You just need to finish it off, the last calculation for each of these problems, so that you get a practice. The way I would study for the test is just do all these problems by watching the video and try to do the problems on your own without looking at any solutions, to ensure that you understand the problems. Make sure that you really understand the problems, understand the concepts. Then when you see similar problems in the midterm, they'll be easy for you. Okay, I hope that this discussion does help you, and best of luck to you, and let me know if you have any questions. Thank you very much.